Why, hello there.
Okay. We'll try it. I don't know. All right. So, just relax for a little bit. Derby, could you get that left light switch for me? Okay. We have a region between two curves from A to B. You're not writing anything down. I want to rotate this about the x-axis. Just enjoy the graphic. If you had me last year, you saw this. If you had Mr. Griebel, I have no idea.
We saw one. He's not as high tech as you, Miss.
No, we saw one thing. He showed us something.
It was like a really fast gift.
Yeah.
So he's probably more high tech because this is probably like super old.
Cool.
But.
I can see the little line.
Yeah,
I like
why?
the different colors.
His is all red. Nasty.
Okay, so we get the idea. Okay. Okay, the question we wish to answer is what is the volume of this solid? So you notice I have all those rectangles, right? We are going to split our region into infinitely small rectangles. And we're going to rotate those around, so we're going to find the volume of these little discs. Or, in this case, washer, because there's going to be a hole in the middle. Okay? So how do we find the volume of a washer? Let's first talk about like a disc. If I had a disc, how do you find the volume?
Just assume pi r squared.
Yep. So pi r squared times the itty bitty height that it has, right? So pi r squared h. Okay, excellent. Now we need to talk about if we have a washer, we essentially have a disc where we're cutting a hole out of the middle, right? All of these are going to be rotated around, but there's going to be a gap. Well, not all of them, not the ones by the x-axis, but so we're going to have to subtract out that hole in the middle. That hole is also a disc or a very flat cylinder, right? So when we talk about finding the volume of this, we have to take the volume of what that solid piece would be, that right there, figure out what the volume of that purple hole is, and subtract it out. Okay? So we have pi r squared h for our outer piece, pi r squared h for our inner piece, and we subtract it out. Okay, well, they both have the same height. They both have the same pi being multiplied to them. So we can really think of this as pi times h times the differences of the radii squared. Okay, yes. Now, back to our region that we make into rectangles. Like Joe just said, the thickness of those rectangles is dx. Okay, so that is telling us we're integrating with respect to x, but that thickness is just the change in x as we go along through that region. So when we make our volume, we can now change that height to dx, and our radii, they're really the distance from, right now, our axis of rotation. Okay, and since the axis of rotation is the x-axis, we're just talking about the function height itself. Okay, so we have the outer function squared minus the inner function squared. And as we sum these together and we take our limit as those change in x's approach 0, like we want our change in x to be itty bitty, we get the integral. Write that down. Okay. Now, right now we are talking about rotating about the x-axis. Yes, we will talk about soon what we do if it's not the x-axis. Okay? But for right now, this gives us an idea of what we need for the x-axis. The biggest thing here is we have radius squared minus radius squared. Okay? So if you need to make a note to yourself, radius squared minus radius squared, that might be a good idea. Okay? But we have pi r squared h minus pi r squared h. Okay? Our h changed into the x. Okay? All right. It's not my favorite example. At your pod, write this down and then work together to draw the region. I want to know what just this region looks like. Your region should look like this up here. That doesn't factor in, does it?
No.
Unfortunate. Okay, here's your picture. Sorry. Do you remember how to identify the x of the vertex? Such an algebra 2 thing.
Yes.
Negative b over 2a. So positive 4 divided by 2 times 1, our vertex is at x equals 2. I don't expect you to remember that, but this would be a picture that I would give you because it doesn't have nice zeros. Okay? All right. Expectations. You will draw a rectangle and label it with your thickness. Why do I want you to do that? I want you to visualize how this is going to be rotated. Okay? I also have this little rotation right here. Okay? I want that to be there too. So I want you to imagine this rectangle popping off of the screen and rotating around the x-axis. What do we get? We get a disc. Okay? That's going to be important when we're mixing in the shell method tomorrow. Okay? If we only had the disc method, I really wouldn't care that much. Okay? So, what? Oh.
Or that.
So we're going to have the integral from 1 to 4, because that's where our x values are, of pi r squared h. So pi r squared, our function height is our radius. Now typically we would subtract out a whole, but you just told me that these are going to be discs. So do we have a whole to subtract out? No. You can put minus 0 squared if it helps you. I probably won't. Here we go. I am going to have you do some integrating by hand on the quiz. I'm going to have you set up and not evaluate. And then I'm also going to have you do it with your calculator. So let's talk about my expectations with your calculator. Go ahead and get it out. Well, it doesn't matter which axis we're rotating about. If we draw a rectangle that its thickness is sitting along the x-axis, we have thickness dx. So no matter how we rotate this, we're integrating with respect to x. If we rotate about the y-axis, which we'll do tomorrow, we have shells. Okay. All right, so if you were to integrate this with your calculator, which I probably would have you do because I don't want to make you have to take the square of a trinomial and then do the right? That'd be kind of, but it would be a lot. I would suggest putting this into your calculator and getting that nice fraction, and then we'll multiply it to pi at the end. So go ahead and put just that into your calculator. Six?
I got
15.6. Okay, so 15.6 pi would not be my favorite answer. So take that 15.6, make it a fraction.
56
Either one would be fine because do I care about reducing?
No.
No, I don't. Okay, we'll just multiply by pi at the end. Okay. All right, do we get to do the same process for rotating around the y-axis?
if the functions are with respect to
We would have to do it in respect to y. So once again, I have some. I'm going to have to erase this. I figured out what makes my recording stop, so I'm trying to avoid that. That's not what we want to see. Okay, you ready? And I don't know why this is dark, but okay, so here's a different region. These two are functions in terms of y. You don't have to write this down. This is another sit back and relax. Okay? Once again, we can break this up into infinitely small rectangles. These rectangles rotate around the y-axis to make discs or washers. And so we have the same thing happening where we have pi r squared minus r squared times h. Our h now, that infinitely small thickness, is change in y. And so now we have dy. And when we add them all together, boom, this is how we do it. What? Oh, okay, okay. So if you need to make a note to yourself, you can. I know some of you are like, oh yeah, same song, second verse, right? Draw this region. We can do this one without a calculator, right? Yes, Mrs. Holman, we can.
Yes, Mrs. Holman.
Thank you. What?
About what are we
Huh.
well, I'm assuming so.
Okay, we could do either one, right? But they would be different volumes. Please understand that. There's not a nice symmetry here, right? Your graph should look like this. Okay. Rotating about the x-axis would be different volume than rotating it about the y-axis. Yes.
Would there be like an area similar to that in the third quadrant? Because it's a cube root, so it's like.
Oh, yes. Maybe I just didn't get all of my example typed out. So I should say first quadrant, right? Because there is a similar. Okay, let's just go. Here's what it would look like, FYI. It's kind of like a ice cream cone, but the ice cream, there wouldn't be very much inside because it's like inverted, right?
I mean, technically, if you wanted the whole thing, you could just find area in the first quadrant and double it.
And then double it. That's very true. That is very true. There we
I
go.
don't think your ice cream would stay in though.
What if you
Did the one on the bottom.
Oh, yeah, no. That would not be good. That would not be good. Okay. By the way, has anyone tried the new ice cream shop downtown Papillion?
Yes.
It's really cute.
It's so good.
It's really good. Saturday. That's your goal. All right. So if we want to go about the y-axis, technically we could draw any rectangle, but we haven't talked about the shell method yet. So if we want to go about the y-axis, I want to draw a rectangle that would create washers. Okay? And we're rotating about the y-axis. Okay? Now, if we have thickness dy, our curves need to be in terms of y. So instead of y equals x over 4, we need x equals 4y. Instead of y equals cubed root of x, we need x equals y cubed, which looks a lot better to do for integration anyway. Okay. So this coordinate is 0, 0. What is this coordinate up here?
2,
2, 8.
It's 8, 2.
I think it would be 8, 2.
No, it would be 2, 8. X
No, coordinates.
Oh. 8.
Yeah. You were thinking 2 for the y, right? Yeah. Okay. We switched everything, so you switched your direction. Okay. So now we're going to set up our integral. Okay. Since we're going with respect to y, we need to go from 0 to 2 because those are where our y boundaries are. Pi r squared minus r squared h. Okay. Pi r squared h. So we have to subtract our radii squares. So which curve is the furthest from the y-axis?
4.
Okay. So 4y is our large radius minus the curve closest to our axis of rotation would be y cubed. Okay. Now this is something I could ask you to do by hand.
So then, if x is still top minus bottom, then now it's flipped for y.
Yes.
So
Well, no,
it's-
it's right minus left. Okay. I, however, am going to start to describe it as furthest and closest because we can't always follow those rules depending on where our axis of rotation is. Okay? Because we could have an axis above, below, wherever. Okay? So let's go ahead and look at something that doesn't have the x or y axis as the axis of rotation. How many times can I say axis in a sentence?
You need to say allies. I like that number.
Okay, go ahead and write down what you need to for this one and draw the region.
Oh, we're moving on.
Oh, yeah. Is it okay if we just set up?
Yeah,
Okay.
I'm okay with that.
Save some time. Okay, so we're going to rotate about the line y equals 4. Okay. So we get this like weird round shape, kind of a bowl.
Earmuff, that's what it is.
Ah, yeah. Or like, what would be? We'd have a hole all the way through, wouldn't we?
So you can hear.
So you can hear. So
Just keep the outside of your ear.
Yeah.
no one cares about the inside of your ear.
No, doesn't do anything anyway.
Okay, so if we are going to rotate about the line y equals 4, and we want disc or washers, probably washers, we are going to want a rectangle that is perpendicular to our axis of rotation, which means it's going to have thickness dx. Did Mr. Grebo tell you that? Okay.
Yeah.
I know
He
he
wasn't
hated
happy
it.
about that.
Yeah, he hated every second of it, but
He was kind of like, no, if you're in Miss Homan's class, she'll say stuff like perpendicular, but we don't need that here.
Don't forget parashell.
we'll get there tomorrow. We'll get there tomorrow. Okay. All right, so here's where it becomes important to talk about our large radius, who's further away, and small radius, who's closer. Okay, so we're integrating with respect to x. So pi r squared minus r squared h. And then our x boundaries would be 0 to 3. Okay. All right, look at that picture.
Would it be 4 minus both of them subtract to each other?
Well, yeah, let's talk about them individually, Joe. So, red or blue, which one's furthest away from our axis of rotation? Blue. So that is our large radius. Since our radius is above, we still have to follow our rules of top minus bottom. So yes, Joe, we would have to say 4 minus x squared minus 2x, the quantity squared. Okay. Then we would need to subtract our small radius. So this red line, it's closer to our axis of rotation, but still, since our axis of rotation is above it, we still have to think about top minus bottom. So we would have to write 4 minus x, the quantity squared. So we still have r squared minus r squared, large radius squared minus small radius squared, still keeping in mind the top minus bottom stuff. Same goes for something around like the line x equals -2 or x equals 15. Okay. Things that I expect. You draw the region. You draw this little rotation. And you draw a rectangle. I won't make you like draw the figure rotating around the axis of rotation. I used to do that, but that was too much. You don't need that. Okay? Region, rectangle, arrow with your setup and work if needed. Okay? Questions?
Maybe that's wrong.
Just use
Yes.
your finger.
153 over 5 pi. And that is worked out by hand. Yeah, no overachiever that day.
You're an overachiever every day, so
I do it for you.